Hi all, myself Dr. K. Ashok, Associate Professor of Physics, Marri Laxman Institute of Technology and Management. Today I am going to discuss about the Hall effect. So basically this Hall effect was discovered by Edwin Hall in 1897, 18 years before the uh, electron invention. So what is the Hall effect? What is the Hall effect? When magnetic field is applied perpendicular to a current carrying conductor. Suppose the current is flowing in this direction, magnetic field is applied in this direction, then voltage is developed in a direction perpendicular to both current and magnetic field. This effect is known as Hall effect. This was discovered by Edwin Hall in 1879. When we consider a conductor, let it be copper. So now you try to apply voltage, here negative and here positive. Then electrons will move in this direction. Electrons will move straightly. Now I will try to apply magnetic field in this direction. Magnetic field is applied perpendicular to the current carrying conductor. Then these electrons will move away from its original path. Means the electrons will accumulate on this side. Here, in this region, the depletion of the electrons takes place. The depletion of the electrons takes place means there indirectly positive charge is accumulated. Positive charge, negative charge separated by certain distance, which is nothing but capacitor. Here the electric lines of force starts and ends here. So electric field is developed. This electric field will tries to move these electrons upward. So magnetic field is moving electrons downward. Electric field is moving electrons opposite direction. Overall, at equilibrium, these two forces are balanced. At that time, whatever the voltage is there, that voltage is nothing but Hall voltage. Here, whatever the voltage, when voltage is there, indirectly electric field is created. That developed electric field is nothing but, assume it as EH. So, whatever the force experienced by electron due to the application of the electric field is F equals to E into E. Here, this field is developed and discovered by Edwin Hall. That's why for honoring him, we represented FH. FH equals to E into EH. Whenever the electron is moving under the magnetic field, it experiences a force. That force is called Lorentz force. Lorentz force is B into like B cross VD into E. Here both of them are vectors. B cross VD is nothing but B VD sine theta into E. Here B and VD are perpendicular. That's why angle between them is 90 degrees. So B VD into E. So Lorentz force is B into VD. When it reaches a steady state, Lorentz force is balanced with Hall force. So Hall force E into EH equals to BE VD. Both sides E and E cancel, so that EH equals to B into VD. From this equation, if you find VD, VD equals to EH by B. VD is nothing but drift velocity. In the material, when no electric field is applied, the electrons will move randomly. When you apply the electric field, particular electric field, then electrons will move systematically. Then they will possess certain velocity. That velocity is called drift velocity. Here the current density is J equals to NE into VD. Here VD from equation 3 I am replacing here. VD is EH by B. From this equation, EH equals to transpose B to left hand side, B into J by N into E. EH equals to JB by NE. This is nothing but Hall field or Hall electric field. Next, we will discuss about the Hall coefficient. So, EH equals to JB by NE. The factor 1 by NE is known as Hall coefficient. So, EH equals to RH into JB we can write. Hall coefficient RH equals to EH by JB. EH by JB. Whatever the conductor we are using, conductor, or we can take semiconductor also. The conductor thickness is T and width is, let it be, D. Then V equals to usually ED. The developed potential V equals to ED. But here the developed voltage we are calling it as VH and developed electric field is called EH for honoring Hall. EH equals to transpose this D to left side. So, VH by D. EH equals to VH by D. RH equals to EH by JB. In the EH, you replace with VH by D. RH equals to VH by D. RH equals to VH by D into here JB. So, J means current density. So, current is confined to area. That's why current density is nothing but current per unit area. Usually, what is area? Length into breadth. So, here T into D. The dimensions are T and D. That's why area, whatever the area is replaced with D into T. RH equals to VH. RH equals to VH by D. J means I by dt. I by dt into JB. So, D cancel. RH equals to this T will go up. So, VH into T by I into B. Here this J is already we are replacing it as I by T. J is nothing but current per unit area. So, what is the importance of Hall coefficient? Hall coefficient is negative for N-type semiconductors. Hall coefficient is positive for P-type semiconductor. So, to determine the type of the semiconductor, this Hall effect is very useful. First one. Next one, to find the carrier concentration, or EH equals to JB by NE. Here N is nothing but concentration of electrons. To find the concentration of electrons also, we will use this one. Even this Hall effect is used to calculate the mobility of the charge carriers. Depending on your applied electric field, what is the movement of the electrons. And even we can use to measure the strength of the magnetic field, the strength of the transverse magnetic field. This is about the importance of the Hall effect. Then what are the applications of the Hall effect? Hall effect in our daily life, if you observe, it is used in magnetometers. In our mobile, whatever the directions we are observing, then magnetometers we will use. Hall effect is used in current sensors to determine how much current is flowing if you want to check. Even in the current sensors, we will use Hall effect. Even Hall effect is used to measure the wheel rotation speed. In normal vehicles, we will use general analog meters, but in digital purpose, we will use these Hall based speedometers. Hall effect, even this Hall coefficient or Hall effect, we can use in sensor applications also. In sensor applications means to find the fuel level. In our vehicle, fuel indicators will be there. Instead of analog, digital point of view, if you want to use, then this Hall effect is used. Totally, the real time applications when we observe in automatic fuel level indicators, in current sensors, in magnetometers, in wheel speed measurements we will use. So this is about the complete Hall effect.